Africa, a continent of awe-inspiring landscapes, majestic wildlife, and untold natural beauty. But hidden beneath this breathtaking scenery lurks a tiny menace, one that has silently shaped the course of history, crippled economies, and devastated communities. Meet the Tsetse fly, barely the size of a paperclip, yet responsible for the suffering of millions. With just a single bite, it can infect both humans and animals with a deadly parasite, one that causes a disease known as sleeping sickness. This is not a new enemy. For over a century, the Tsetse fly has ravaged sub-Saharan Africa, forcing entire populations to relocate, wiping out livestock, and turning once fertile lands into zones of fear and abandonment. Spanning over 36 countries and more than 10 million square kilometers, the Tsetse fly's reach is vast, yet it remains largely unknown to the outside world, a shadow in the backdrop of Africa's environmental and humanitarian struggles. But hope is not lost. Scientists, conservationists, and local communities are fighting back. Through innovation, education, and sheer resilience, they are working to defeat this tiny tyrant once and for all. In this documentary, we journey deep into the world of the Tsetse fly, from its biology to its deadly impact and the remarkable efforts to stop it. We uncover the hidden truth behind one of Africa's most feared insects. This is the story of the Tsetse fly, a small insect with a deadly legacy. At first glance, the Tsetse fly may look like any other ordinary housefly. But don't be fooled by its modest appearance. This insect belongs to a unique genus known as Glossina, and it's unlike any other fly on Earth. Measuring between 6 to 15 millimeters in length, the Tsetse fly has several distinct features. Its wings fold completely over one another, forming a characteristic scissor-like shape when at rest. But its most dangerous weapon lies right in front, its proboscis, a needle-like structure used to pierce skin and suck blood. Both male and female Tsetse flies are hematophagous, meaning they feed exclusively on blood. Unlike mosquitoes, where only the female bites, every adult Tsetse fly needs blood to survive. Their victims range from wildlife and livestock to humans, and while the bite alone is painful, it's what the fly carries that poses the real danger, a microscopic parasite called trypanosoma. This parasite lives inside the fly's gut and salivary glands, waiting for the perfect opportunity to be transmitted into a new host through the fly's bite. Once inside the body, it multiplies and spreads, eventually causing life-threatening disease. There are over 30 recognized species of Tsetse flies, grouped into 3 categories: savanna, riverine, and forest species, each with their own preferred environment and host range. But they all share one chilling trait: the ability to spread disease with a single bite. Fast, agile, and persistent, the Tsetse fly is a predator in its own right. It can detect body heat, motion, and even carbon dioxide from dozens of meters away. Once locked onto a target, it homes in with deadly precision. It is this efficiency, as both a hunter and a disease vector, that makes the Tsetse fly one of the most dangerous insects on the African continent. To find the Tsetse fly, you must go where the wild breathes deepest. They thrive in the lush river valleys, shaded savannas, and tropical forests of sub-Saharan Africa, regions teeming with life, but also danger. These flies are highly selective about where they live. They prefer humid, warm environments where their hosts, wild animals, livestock, and humans, frequently pass through. Vegetation provides the shade they need to avoid overheating, while water sources offer the perfect breeding conditions. Unlike mosquitoes that often operate under cover of darkness, Tsetse flies are active hunters during the daylight hours. They rest on tree trunks, bushes, or the undersides of leaves, patiently waiting for movement, warmth, or the telltale signs of breath. With their highly developed vision, they can spot movement from up to 30 meters away. They're drawn not just to the shape and motion of potential hosts, but also to the heat and the carbon dioxide we exhale. When they strike, it happens quickly. In a flash, the Tsetse fly lands on its host and drives its proboscis through skin to locate a blood vessel. The bite itself can be painful, and it leaves behind more than just a red mark. With each bite, there's a chance that the trypanosoma parasite is injected into the host. From that moment on, the disease process begins, sometimes silently, sometimes swiftly. For livestock, this means weakened immune systems, weight loss, reproductive failure, and often death. For humans, the first signs may feel like the flu until the parasite begins to attack the nervous system. Over time, communities living in fly-infested zones have developed strategies to reduce exposure, using smoke, repellents, insecticide-treated animals, and netted enclosures. But in many remote regions, the fly continues to dominate the landscape. Stealthy, persistent, and perfectly adapted, the tsetse fly has made the African wilderness its kingdom, and in its domain, it reigns supreme. It begins with a bite, often painless, frequently unnoticed. But within that moment, a silent war begins inside the human body. The tsetse fly transmits a microscopic invader, Trypanosoma brucei, the parasite responsible for human African trypanosomiasis, more commonly known as sleeping sickness. Once inside the bloodstream, the parasites multiply rapidly, invading organs, lymph nodes, and eventually, if left untreated, the brain and central nervous system. The first stage of the disease often feels harmless: fever, headaches, muscle aches, swollen lymph nodes. But over time, the symptoms grow more sinister. As the parasite crosses the blood-brain barrier, victims begin to suffer personality changes, hallucinations, and severe sleep disturbances, where days are spent in exhaustion and nights in restless wakefulness. Left untreated, the disease progresses into seizures, coma, and eventually death. Sleeping sickness has historically plagued the heart of Africa. Major epidemics have swept across the continent, from the Congo to Sudan, from Angola to Uganda, leaving thousands dead and millions at risk. In the early 20th century, sleeping sickness killed hundreds of thousands. Villages were abandoned, trade routes collapsed. Colonizers, missionaries, and local leaders alike feared its devastating spread. But humans are not the only victims. A closely related disease, called nagana, affects animals, particularly livestock. It leads to chronic wasting, infertility, and eventually death, decimating cattle herds and crippling agriculture across the Tsetse belt. In many regions, this disease has made it nearly impossible to raise cattle or cultivate crops. The economic loss is staggering, measured not just in dollars, but in hunger, lost labor, and shattered communities. Yet despite its danger, sleeping sickness is treatable, if diagnosed early. But in many remote areas, access to proper diagnosis and treatment remains a major challenge. Non-profits and health agencies are racing against time, deploying mobile clinics, rapid diagnostic tests, and life-saving medicines. Thanks to decades of effort, the number of cases has dramatically fallen, from tens of thousands per year in the 1990s to fewer than 1,000 today. But the battle isn't over. So long as the tsetse fly lives and bites, the threat of sleeping sickness remains. For the communities living within the vast Tsetse belt of Africa, this fly is more than a nuisance. It's a threat to their way of life. Over 70 million people across 36 African countries are at risk of infection. These are farmers, herders, teachers, children, ordinary people whose lives are disrupted by an invisible parasite and its relentless carrier. In regions infested with tsetse flies, raising cattle becomes nearly impossible. The disease known as nagana, which strikes animals, causes weight loss, miscarriage, and death in cows, goats, and donkeys. For families who depend on their livestock for milk, meat, transport, and income, it's a devastating blow. When livestock die, agriculture suffers. Fields go unplowed, markets lose their produce, families lose their livelihoods, food insecurity rises, and so does poverty. Over 10 million square kilometers of arable land, an area larger than the entire United States, is considered unsuitable for farming or settlement due to the presence of tsetse flies. Entire regions have been abandoned or avoided for fear of disease. Even education is affected. Children infected with sleeping sickness struggle to concentrate. Many are too weak to attend school. Their future, once full of promise, slips away with every undiagnosed case. And then there's the emotional toll. Caring for a sick family member often falls on women, who must juggle domestic duties, farming, and long journeys to distant clinics, if treatment is even available. In some villages, the fear of the tsetse fly is passed down through generations. Elders recall the time of great epidemics, entire villages vanishing, children dying in their sleep, livestock gone overnight. Over the years, communities have adapted. They burn fires, build animal enclosures, and use protective chemicals. But these are only partial solutions. The fly keeps returning, season after season. Economists estimate that the tsetse fly costs Africa over $4.5 billion every year in lost livestock productivity alone. The human cost of lives lost, dreams deferred, and communities weakened cannot be measured. Yet, hope remains. In regions where the fly has been pushed back, prosperity begins to return. Healthy cattle, thriving farms, children laughing in schoolyards. When the fly disappears, life reappears. The tsetse fly's power doesn't come from numbers, it comes from persistence. While other insects lay hundreds of eggs, the tsetse takes a different approach, one that's strangely sophisticated and surprisingly slow. Unlike most insects, tsetse flies give birth to live young. The female doesn't lay eggs. Instead, she carries a single larva inside her body, nourishing it with a special milk-like substance from internal glands. Over a period of 9 to 10 days, the larva grows inside the mother until it is fully developed. When the time is right, she gives birth, not in water like a mosquito, but on solid ground. The larva immediately burrows into the soil, away from predators and heat, where it enters the pupal stage, a hardened cocoon-like shell that protects it while it transforms. For the next 3 to 4 weeks, a remarkable metamorphosis takes place. Then, the fully formed adult tsetse fly emerges, ready to feed, mate, and begin the cycle anew. A female tsetse fly will typically produce only 8 to 10 offspring in her lifetime. This may seem small compared to other insects, but each one has a high survival rate, thanks to the mother's protection and the pupal shell. Tsetse flies live around 2 to 4 months in the wild. During this time, the female mates only once, but stores the sperm for future births. Every 2 weeks, she releases a single larva. This slow reproductive process is a double-edged sword. It means populations grow slowly, but it also makes them vulnerable to targeted control efforts. Remove enough females from the population, and the numbers can collapse within a few generations. Today, researchers exploit this weakness. Through the sterile insect technique, lab-bred male flies are sterilized using radiation and released into the wild. When they mate, no offspring are produced, cutting the population silently from within. From live birth to pupal shell, the tsetse fly's life is a study in precision, survival, and subtle vulnerability. For decades, the tsetse fly held entire nations hostage, its bite a barrier to health, progress, and prosperity. But today, the tide is turning. Across sub-Saharan Africa, a coordinated effort is underway. Scientists, healthcare workers, governments, and local communities have joined forces in the fight against the tsetse fly and the diseases it spreads. One of the simplest yet most effective tools, the tsetse trap. Brightly colored and baited with chemical attractants, these traps lure flies with the promise of a meal and silently eliminate them. Livestock is also being used as living defense systems. Cattle treated with insecticidal sprays or porons kill flies upon contact. These treated animals help reduce tsetse numbers while protecting entire herds from infection. Then there's the cutting-edge approach, sterile insect technique, or SIT. Scientists raise male tsetse flies in special facilities, sterilize them using radiation, and release them into the wild in massive numbers. When these sterile males mate with wild females, the result is nothing. No offspring, no future generation. Over time, fly populations crash without a single drop of insecticide. On the front lines of healthcare, rapid diagnostic tests are making it easier to detect sleeping sickness early, before it becomes fatal. Medicines have improved too, with safer and more effective treatments now available, even in remote areas. The results are real. In the 1990s, Over 30,000 cases of sleeping sickness were reported each year. Today, thanks to global cooperation, that number has dropped below 1,000 annually. But science alone isn't enough. Community engagement is vital. Villagers are trained to recognize symptoms, set traps, and report cases. It is the people themselves, those most affected, who are now leading the charge. Governments are stepping in too, integrating Tsetse control into broader public health plans, investing in land management, and supporting regional programs that span borders and ecosystems. With sustained effort, many experts now believe a bold vision is within reach: the complete elimination of sleeping sickness by 2030, a future where the Tsetse fly no longer controls the fate of millions. In the eyes of many, the Tsetse fly is nothing more than a villain, an insect of disease, suffering, and destruction. But in the delicate web of African ecosystems, even villains have a role. For over a century, the threat of the Tsetse fly has acted as a natural barrier to human expansion. Entire regions, lush, fertile, and full of life, have remained undeveloped, largely because the fly made them too dangerous to inhabit. Ironically, this has allowed vast stretches of Africa to remain wild, untouched by agriculture, industry, or urban sprawl. In these protected havens, lions still roam freely, elephants graze undisturbed, and forests echo with the calls of primates and birds. Without the Tsetse fly, these landscapes might have been ploughed, paved, or overgrazed. The fly's presence has, in a sense, bought time for nature to survive amid a rapidly changing continent. Some ecologists argue that the Tsetse fly, while dangerous, has indirectly preserved biodiversity. Its shadow over human activity has allowed entire ecosystems to flourish, especially in regions where conservation efforts are weak or underfunded. This creates a difficult question. What happens when we finally eliminate the fly? Will wild areas be lost to farming and development? Will the absence of disease bring prosperity, or will it bring bulldozers? The answer is not simple. While the elimination of sleeping sickness is a clear victory for public health, the conservation implications must be managed with care. The goal is not to trade one loss for another, but to balance human needs with environmental stewardship. Fortunately, new models of development are emerging, ones that protect both people and nature. With the right strategies, it's possible to unlock the land's potential without destroying its soul. The Tsetse fly may soon disappear, but the choices we make in its absence will shape the future of Africa's wilderness. A century ago, the Tsetse fly brought death and displacement to vast stretches of Africa. Today, the landscape is changing, not because the fly has given up, but because humanity is fighting back, smarter than ever before. The future of the fight lies in innovation, integration, and inclusion, harnessing cutting-edge tools, uniting global partnerships, and empowering the very communities most affected. Drones now monitor Tsetse habitats from the sky, mapping fly movements and population clusters with pinpoint accuracy. These eyes in the sky allow scientists to target interventions with surgical precision. Advances in genetic engineering are also being explored. Scientists are experimenting with gene drives, genetic modifications that could potentially render entire fly populations infertile or resistant to the trypanosoma parasite. In the field, mobile health technologies are bringing rapid diagnostics and treatment directly to remote areas. Portable kits powered by solar panels detect infection within minutes and deliver life-saving care on the spot. Meanwhile, communities are being equipped with knowledge and tools. Education campaigns teach residents how to set traps, apply safe repellents, and recognize symptoms early. At the policy level, African governments and international agencies are collaborating like never before, sharing data, aligning strategies, and pledging to eliminate sleeping sickness by the year 2030. It's an ambitious goal, but not an impossible one. With fewer than 1,000 cases reported each year, total eradication is now within sight, a historic achievement once thought impossible. The future also depends on sustainability. Eradication must go hand in hand with long-term land management, sustainable farming, and wildlife protection. Otherwise, the fly, or the chaos it once contained, may return in another form. The story of the Tsetse fly is not over. It is being rewritten, page by page, by every scientist, every herder, every mother who refuses to let this ancient menace define their future. Africa's battle with the Tsetse fly has lasted for generations, but in this new chapter, it may be the human spirit, and not the insect, that leaves the greater legacy. The Tsetse fly, a tiny insect with a deadly legacy, has shaped the lives of millions and the landscapes of an entire continent. From spreading the fatal sleeping sickness to forcing changes in human settlement and land use, its impact has been profound and far-reaching. But the story is not one of despair. Thanks to science, determination, and community resilience, hope shines brighter than ever before. Innovative control methods, improved healthcare access, and empowered local communities are turning the tide in this age-old battle. As the Tsetse fly's shadow recedes, new opportunities arise. Opportunities for health, growth, and a future where the fly no longer holds sway. The fight against the Tsetse fly is far from over, but with continued effort and unity, a world free from its bite is within reach. This is the story of the Tsetse fly, a tiny insect, a mighty challenge, and the hope for a brighter tomorrow.